Okay, let's do permutations and combinations. So this is a probability chapter. It's kind of fun. There's your homework assignment. Let's start with something easy and basic called the fundamental counting principle. It sounds kind of complicated there, but let's look at an example to see what this looks like. So this is a pretty typical example of the counting principle. So it says that if there are three types of bread, um, maybe at a Subway place or something, five types of meat, and four cheeses at a sub shop. How many different ways can you make a sub if you get to choose one of each? So this might be obvious to you. It might not be obvious to you. Some people can kind of think this way. But what this says, if you can occur in m times n ways, so it's really like there are three types of bread. So that's like m. There are n ways would be like five types of meat. So that's like so there'd be 3 times 5. And then we have one more. I guess technically we're applying the counting principle twice here. So there are 4 cheeses, so times 4. So 3 times 5 is 15, times 4 is 60. So there are 60 different ways to make 60 different sandwiches that you can make. By the way, a way of visually seeing this, maybe this would help you. I'm not sure if it would. But if you want to look at the types of bread, that would be 3 different types of bread. So you've got 3 types of bread. You got 5 types of meat. So each one of these would have 1, 2, 3, 4, 5. You have to make a meat choice after you make a bread. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Kind of running in a room there. And then I guess you need to make a cheese choice at that point. So let's say you make your 4 cheese. So there would be 1, 2, 3, 4 cheeses out of each one of these ends here. And if you counted all these different ones, if I kept going with that, there would be 60 different possibilities. You got 3 for the bread, 5 for the meat, and 4 for the cheese. And so you can just multiply those. That's the fastest way of doing that. I call it kind of the slot method, like making 3 slots and just multiplying those numbers together, whatever they are. Here's a good example of little tougher problems. How many license plates were possible in 2007 and in 1912? So let's figure this out. So this one would be Maryland in 2007 had 3 letters. So I'm going to make 3 slots for the letters, and then 3 numbers or 3 digits, so 3 slots for that. So this would be a pretty big number. So let's just see, 26. There are 26 different letters you could use, times 26, times 26, times how many different digits? 0 through 9. So there would be 10 different digits, times 10, times 10. And you just use your calculator, multiply that out, get some huge number there for the number of license plates in Maryland. And then here for in the year 1912 in Maryland, they didn't have as many cars back then, so there were only 4 slots I really need to fill here. So that would be 10 times 10 times 10 times 10, which I can do that in my head. I think that's 1 with 1, 2, 3, 4 zeros. So that's 10,000 for that one. And again, it didn't mention this, but if they said no repeats were possible, then this would change. This would be 10 times 9 times 8 times 7. But they didn't mention repeats, so you're going to assume a repeating is allowed, so it would be 10,000 there. And then just get your calculator out and just type in 26 to the third power. 26 times 26 times 26 times 10 times 10 times 10 is this huge number here. What is that? 175, 175, sorry. 76000. So it looks like about 17 million. I guess we would subtract 10,000. Oops. So whatever 10,000 minus that is, so that would be 17,566,000 would be the difference between the two. So if I subtract 10,000 from that number, you get that number would be the number of license plates difference. So in how many ways can you file 12 folders one after another in a drawer? So you're doing a slot method here, the slow way of doing this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, is going to be 12. The first file folder you choose, there's 12 options, but once you've chosen the first choice, there's only 11 left, kind of like with no repeats. Then 10, then 9, then 8, then 7, then 6, then 5, then 4, then 3, then 2, then 1, and multiply those all together. And you can definitely do that in your calculator. But it's going to be much faster to just type this in your calculator. You can actually type in 12 factorial. I'm not sure if you've ever done that before, but on T-Inspire, the way you do that is you type in 12. Then I think this key over here on the right here, I think it has an exclamation point. Is that it? There it is. So it's going to be 479, whatever that number is. So you got that value right there that you can drag in there. So again, you just type it in your calculator and you'll get the answer. That's the same thing as typing in 12 times 11 times 10 times 9 all the way down to 1 there. It's called a factorial. So it's a fast way of writing it. And so we're going to use those factorials sometimes to do a problem. So here, let's do it the factorial way. So there are 10 runners in a race. How many different ways can they finish? You could make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 times 9 times 8, etc. Or just type in your calculator 10 factorial and you get the answer very, very quickly. So that would be the answer, whatever that is, when you type it in your calculator. Let's get to a little tougher problem. So this one, similar to the last one, 10 runners a race, but now we only care about if you finish on the medal stand. First, second, and third place, gold, silver, and bronze. That's all we care about in the Olympics. So how many ways can 10 runners finish on the medal stand? So that's a little different question. So there's really only 3 options here. So there's going to be 3 slots. We're going to multiply, similar to what we've done before. So there are 10 ways the first runner can finish. After you decided to use first, there's 9 runners left over, and then 8. Whatever that is in your calculator. I guess you would do 10 times 9 times 8, which is 720. So we get an answer of 720. And that's one way of doing the problem. Now, there's a fancier way we can do it called using a permutation. So when order matters, and in this case, the order does matter. We're trying to get first, second, and third place. And so when order matters, we can use a method called permutations. So order, that's the key thing. Permutations when order matters. And so this is called NPR. So in this case, our N is like the number of possible outcomes. There are 10. And our R in this case would be how many we're actually choosing. We're choosing 1, 2, 3. We're choosing 3 of those in a certain order. And so this would be equal to, if we want to write it this way, this would be 10P3, 10 permutations taken 3 at a time. Now, formally, using the variables, this would be 10 factorial over 10 minus 3 quantity factorial. So that's really 10 factorial over 7 factorial. Now, you could actually do this by hand, I think, or pretty close to it. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 7 factorial will be 7 times 6 times 5 times 4 times 3 times 2 times 1. And so what you see might happen here, or what does happen, is the 7s cancel, the 6s, the 5s, the 4s, the 3s, the 2s, the 1s. And we're left with what we did up here, 10 times 9 times 8. So it's almost easier to just do it with the slot method here, but we could actually use permutations. And so the cool part is there's a way to just type this in your calculator. So get your calculator out. And if you hit the menu key, it's probably under statistics or probability. Let's go to probability. And probability, it is called a permutation. There you go. Permutation NPR. So we're going to put 10, comma, hit the comma, and then 3. Comma is right there near the bottom left of your screen. And press enter. And it says the answer is 720. So it's a very fast way of entering a permutation into your calculator. I will not require you to memorize this or even use this. I am fine with you using your calculator. Problems are tough enough in probability, just setting it up. If you know, oh, this is 10p3, this is a permutation, order matters. I care what order they're finishing in, and so that would be the way to go on that one, is just go ahead and do NPR on your calculator. It's a little different type of problem here, a little nuance here. So this one, it says a pizza place has 5 toppings available. If you order a large pizza, how many different pizzas could you make if you choose exactly 2 toppings? So let's pretend let's call the toppings A, B, C, D, and E. So let's list out all our possible topping combinations. So let's start with A. So I could choose A and B. I could choose AC. I could choose AD. And I could choose AE. I guess my question is, does order matter? In other words, should I put like BA, CA, DA, AEA? For picking pizza toppings and you say I want pepperoni and mushrooms, does it really matter if they put the pepperoni on first and then the mushrooms? You probably won't even know. And so order doesn't really matter in this case. So because order doesn't matter, we're going to use combinations. We'll talk about that in just a minute. But this is not a permutation problem. Order is not important in this problem. And so I don't need to consider every case. So this, writing out all these things that I'm about to do, I'm not finished yet, is called the sample space. Sometimes in a tough problem, it's good to go and write out the whole sample space. So let's do all the B's next. So I could be BC. I already have BA represented. It could be BD or BE. I think I have all the B combinations. Let's go with C's now. CE, CD, CE. I think that's it. And then D, E. I think I've got every single possible combination there is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You might have even noticed a pattern there. You might could have not quite finished once you kind of figure out 4, 3, 2, 1. You're adding up 4 plus 3 plus 2 plus 1. 10 is the number of different possible pizza combinations. Let's do this the kind of same question. Let's do it using when order doesn't matter. So n is the number of possible combinations. In this case, there were 5 toppings. But how many are you choosing? So R is how many at a time, so we're choosing just 2 of those 5. So according to the formula, this would be 5, choose 2. This is not, when order doesn't matter. So order doesn't matter in this problem. We don't care which order the toppings are given in, but we're choosing 2 of the 5. And so this would be the fraction 5 factorial over 2 factorial times 5 minus 2 factorial, all quantity factorial. So this ends up being 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. And if we do this, this is really 3 factorial, which is 3 times 2 times 1. So if I cancel everything out, that would be 3, 2, 1. Those cancel. I guess the 4 and 2 cancel, and there's a 2 left over. So that would be 5 times 2 over 1, so 10 over 1, or 10. So we get the same answer algebraically. And by the way, I will definitely let you type this in your calculator. So you just have to know where to find it. Menu, I think it's under probability. And that would be a combination, so NCR. So it'll be 5, choose 2. So 5 comma 2, and press enter, and you get 10 as the answer there. So again, it's a way to do it in your calculator instead. There you go. That's your lesson on permutations and combinations.